Today's episode of On Orbit is brought to you by AVL Technologies, a leading manufacturer of multiband and multi-orbit satellite communications ground terminals serving both government and commercial markets. With terminals ranging in size from 60 centimeters to 4.6 meters, AVL provides efficient, cost-effective solutions for voice, video, and data connectivity without the need for specialized training. AVL's innovative and visionary approach to engineering and design ensures the critical requirements of today's missions are met. For more information, please visit avltech.com. That's avltech.com. And now, on to our episode.
The satellite-connected car has long been seen as a future market for the satellite industry, but hasn't broken through to the mainstream yet. But now, recent developments in standards and technology are bringing this closer to reality. In this week's episode, I interviewed two experts from BMW Group, Olaf, Eckart, and Georg Schmitt, about the roadmap for integrating satellite connectivity into cars. Olaf and Georg are both experts in vehicle connectivity, and they lay out the use cases where satellite makes sense, some of the challenges specific to the automotive industry, and the roadmap for integrating satellite into vehicles from narrowband to wideband to broadband. It's a really interesting discussion to hear from a major automotive manufacturer about the work going into this area and the potential they see for ubiquitous connectivity in vehicles. I'm Rachel Jewett, and you're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Olaf and Georg. Thanks for joining the On Orbit podcast.
Hi, Rachel. Also, greetings from us. It's a pleasure for us to be in your podcast.
Oh, thank you. I wanted to have you both on the podcast to hear about the automotive perspective of satellite connected cars. So I've been seeing a lot of news and updates from the satellite sector that things are really starting to pick up in this area. And with both of you part of the 5G Automotive Association, there were recently some connectivity demonstrations, which I'd love to hear more about too. So to get us started, I'd like you to just tell me a little bit about yourselves and your work with BMW. Georg, do you want to start?
So my name is Georg Schmitt. I'm within BMW, the development department responsible for the onboard vehicle connectivity. And there I own the connectivity strategy and the pre-development research activities I drive. And I'm linked to satellite connectivity automotive since 2.5 years.
Awesome, thanks. And Olaf, what about you?
Yes, I'm in the early stage innovation department of BMW, and I'm specialized in partner management. So we support the early stage research projects and development projects with sophisticated partner management. And in this case, we are building and managing the partner networks which are necessary to develop such topics.
Awesome. And then, so is part of your work to interface with the 5G AA organization?
Yeah, actually, the 5G AA is, from our point of view, a perfect platform to get involved with the so-called ecosystem. So we are enabled to communicate with other OEMs and also with other telecommunication companies. And 5GA basically provides a very good global communication platform, and we can reach out and drive our projects. And it's a very good thing to align with other companies in the communication field.
Interesting. So talk to me overall about the push to expand connectivity within vehicles. And before I get into satellite, but just the connectivity environment in vehicles overall, and why you're looking to make vehicles more connected.
Georg, shall I start?
Yes, please. Mm-hmm.
Yeah, yeah. From our point of view, the vehicles are already connected a long time. So as you know, you can use you can make phone calls. You have intelligent navigation systems. The car is also connected with the back end, and there are more and more applications coming to the various automotive fleets, and therefore connectivity is becoming more and more important. And you also know that most of the time the cars are connected in the terrestrial networks, but unfortunately there are also coverage gaps, and for us satellite connectivity is a complementary extension to this connectivity. So in areas where we have coverage gaps, or in situations where there are like disasters, or where the terrestrial network is broken down, in this case the satellite networks are a real good replacement and a good extension for us to stay connected.
So what is kind of the roadmap of satellite and non-terrestrial networks for adopting satellite connectivity into vehicles? What is kind of where are we at right now, and what does the roadmap look like?
Yeah, maybe we also have to look back a bit. So when we started with the whole topic, on the one hand, we knew that satellite connectivity could be a good way forward for us. But on the other hand, we recognized that at this time, satellite connectivity was rather expensive. There were mostly proprietary satellite systems, which were rather expensive. You needed very large and costly ground equipment and antennas, and then we found out that the only way to make it cost effective is to push for solutions where the satellite connectivity is integrated into the terrestrial connectivity, and where the satellite connectivity applies the standards which are already used on the ground. And the second major factor is that we also need to take into account that the mobile handheld industry uses the standard as well, and this is already a mass market, and therefore automotive industry is benefiting from a huge market which is already existing on the ground, and therefore it is logical that we try to expand these mechanisms into space and to rely on the same mechanisms.
It's a very important topic that Olaf mentions. We leverage this huge billion handhelds per year ecosystem on the automotive side, with the just some millions connected. Perhaps it's now up to 50 or 60 million connected vehicles issued per year. We are a tiny market, so we have to participate on that. But, and that is key, Olaf will explain it now in more detail, we have automotive specifics, and those we have to be considered. Otherwise, we cannot use satellite connectivity within the vehicles, and therefore also the 5GA as an automotive association is key from our perspective, as we have all the vertical within the association that are part of the ecosystem, or let's word it like that. we have managed that also now they are in we need for satellite business. It was a huge work, and I want to thank here Olaf, the 5GA, that we could bring into the satellite operators and their ecosystem players into the 5GA, and so now to elaborate what are the automotive specifics, to have then finally, and that on a roadmap perspective, the satellite connectivity within the vehicles in the future.
Yeah, so what are some of those specifics to automotive that need to be taken into account to adopt satellite connectivity?
Yeah. For instance, and that's very specific for the automotive industry, is that we have limited space to integrate any kind of connectivity equipment in our cars. There is also the energy consumption, which we need to consider, that it needs to be very low. And if you look to standardization approaches, and then how the large organizations like the 3GPP are working, you see that in the past they were only aware of the handheld antennas, and this were part of the mobile standard system. Mm-hmm. And they also started to integrate some large 60 centimeter parabole antennas, which were not suited for us. So, and therefore we started to describe the applications which are important for us. We also derived the requirements, like how much data rate the applications need, and also what latencies they need and such things. And from these values, we also derived antenna parameters, which are suitable for us and which would also be strong enough to communicate with satellites and enable this kind of connectivity. And therefore, especially bringing these antenna parameters into the discussion, this was key for us. And from today's point of view, we can already say that for the frequencies in which we are working, the antenna parameters are now recognized. And in one of the next 3GPP releases, these parameters will be part of standardization. So that's really key for us, because now this would allow us to integrate seamlessly into the system and only to make very small changes within our cars and to be part of this connectivity technology.
Oh, that's really exciting. So would that be in 3GPP 19?
Yes, that's a very good point. So the first rules, I mean, it already started with release 15, but with release 17, the first NTN IoT rules have been integrated. But with release 19, the so-called high power UEs for the frequencies below 6 gigahertz are part of the standardization. And so you can imagine, once these parameters are now in the process, then all the chip manufacturers, the antenna manufacturers, everyone can use these values and can develop chips and devices. And finally, we will be able to integrate this technology into our cars in the upcoming years.
Oh, very exciting. And what are some of the applications that satellite makes sense for with vehicles?
Maybe just to start on the very high level, mm-hmm. we have clustered the applications which are apparent to us into three categories.
Okay.
So distinguish between so-called narrowband data rate applications, and these applications just use less than 400 kilobit per second. Then wideband applications up to 10 megabit per second, and broadband applications which use or consume more than 10 megabit per second. And none of these applications are new. They are basically the same as we are already knowing from today's terrestrial connectivity. And just to give you an example, for the narrowband applications, a famous example is the so-called voice call or third-party emergency calls. We also are able to bring so-called remote services, remote access services to the car. So we are able to control windows, doors, air conditioning, heating from remote. And we can also basically establish kind of digital twin of the car in the back end, so that we know what our cars are doing and whether they need, whether there's a need for repair or anything like that. Mm-hmm. Yeah, and just to add some wideband data rate applications. These applications will become more important at the stage where we have more and more cars on the road with automated driving functions. The need for data exchange for these kind of cars is much, much higher. So these cars need most of the, like the road condition, the hazard warnings, and everything which is around them. They need to be informed, and therefore the need for data will grow considerably. And finally, for the broadband use cases, you are probably aware that the demand for video streaming, video conferencing, also in higher resolutions, is growing fast, and therefore we are also quite sure that this will be one of the most important applications in the future.
Interesting.
So perhaps to add here, yeah. The good news is, and that was what we demonstrated in Paris during the 5G demonstrations, is that with the narrowband data rate, we already can target use cases that are very, very essential. Yeah, they target safety, emergency situations, hazard warnings. And that's the good news, because you can, with such data rates and having this with so-called narrowband IoT, NTN being transmitted, you can, in rural areas without any coverage, you can really connect to the vehicles, you can guide the drivers, you can assist them, and so on. And that is, I think, especially for countries that have a lot of white spot, because there's a very huge countries like we have in the United States. There are also countries in Europe, and especially we look at here on Germany, we have white spots there, that means no coverage, where such functionality to have coverage and support safety-related use cases will be essential in the future.
Yeah, so on those demonstrations, so this was a couple weeks ago in Paris, is that right?
Correct.
Yeah.
There have been the world first, I would say, demonstrations involving satellite according to the 3GPP standard, release 17, in vehicles, with vehicles, and there in a static environment, and also in a driving on the road conditions.
Yeah. So tell me about one of like the specifics, and give me Tell me all about the demonstration.
So there basically we had we had two demonstrations that were on the road that I will introduce right now, and the others later. So there we had two demonstrations. One was with BMW, and there on the satellite side it was this Viasat Skylo and Deutsche Telekom from the overall ecosystem, and there we showed the emergency messaging and hazard warning. So what we could show that you were driving. We were driving with a car that had somewhat disabled terrestrial communication. We were driving at a defined route and could then show here that via connection to our backend system to induce here hazard warning messages. We had to introduce them because there was no heavy rain outside. Yeah, so it was a very sunny blue sky day.
Not a day of hazards.
Yeah, so we had no hazards. So we showed we somehow triggered them with our backend, and then they arrived. Here we could show really what it's about. They arrive, but of course they don't somehow instantaneously arrive. That's due to the nature of a narrowband IoT. It's a very low bandwidth in the configuration we used. It was a geostationary satellite. They are very far above. Yeah, so these 36,000 kilometers above, and it's for me always a miracle that we really can exchange here these messages. And of course, you only can exchange a few messages per minute. Yeah. So the overall, and so we could really show while driving around, and had the visitors with us in the car could really show to trigger the message, and of course take some time. It receives if it warns you about the hazard. That was the first part, and the other part was really that we somehow simulated a breakdown, where you now are in a coverage-less area, and then you trigger an emergency message, and that is sent to the BMW center, emergency center, and there's all the data received, like the geolocation and so on, and the status of the vehicle, and so then you can request to get help at that in such a moment. Yeah? And that this we could show. And the second on the road was to the colleagues from LG Electronics. They showed that where we really now drive, especially with our team, with the 5G and others, is really the seamless interaction between terrestrial networks and non-terrestrial networks. Yeah, so if the terrestrial network is not more available, then we use switch and can somehow seamlessly use the satellite network. That was demonstrated. So the colleagues were driving around and had areas without terrestrial coverage, and showed that then messages that had been formerly sent to a server via terrestrial networks, where then later the answer was received via satellite. Yeah. So really directly showing how this is the connectivity is now from a technology perspective seamless, yeah? But from the customer it's the customer's experience means seamless. It's somehow invisible that he's now connected to our satellite network. So he has then this also the miracle of having a ubiquitous connectivity. Mm-hmm. So that were the two demos we had there, and the other static demos in vehicles showed really the full integration into the vehicles and the already today availability of a telematics unit that somehow off the shelf could be ordered, is made available by a tier one, to be integrated by the car makers.
Okay. When you talked about ubiquitous connectivity, I mean, I feel like that's the key, is that the person in the car doesn't know or doesn't care where the connectivity is coming from. So that's very exciting.
Yeah, and it's perhaps Olaf, can you explain you a bit then the roadmap for the next years, what you said, and because with the seamless, so we have now on the starting point, yeah, and we wanted to show in Paris, hey, now this becomes real, yeah. That's amazing. That this can be made available for the mass market. Yeah? If you, it's not that you have to buy like you had in the past a Satcom smartphone with a specialized contract that was very expensive, but you get this really in the future on the smartphones, as has been, but you will get it in the cars, and especially it's important in the cars. Because with the cars, you really target rural areas that have the without coverage much more or easier than you would do this as a pedestrian. Yeah? Of course, you also can hike in a desert or in the mountains, but with the car, I think much more people will drive and will experience that they need connectivity. Mm-hmm. Olaf, will you perhaps shortly give an insight? What is the roadmap? What we will expect in the future? We now showed a starting point with narrowband IoT in Paris. What would be a vision and roadmap for the next years?
Yeah, I think that's also a part of the work we have done. In general, we wanted to create a joint vision, and that's very important. As soon as many stakeholders want to cooperate with each other, they need to have somehow the same target. So we have started with what are the most important applications and the requirements, also the antenna parameters. So the other dimension, which is very important, is timing. And as you know, the automotive industry has long lead times, and it takes for them 3 to 4 years more compared to the handheld industry to get the technology into the car. Yeah. And what we have done with the end-to-end roadmap is basically that we have looked what technology is already available, what satellite constellations are already in space, and what satellite constellation and what satellite technologies will be available in the future. And if you take all this information together, we came up with the result that we will see mostly 3 steps how the satellite connectivity will be deployed in the near future. We believe that the first mass market applications with NTN narrowband IoT applications will probably be deployed from 2027 on. So this will be the first time when the first OEMs will have integrated the Release 17 chips, which are now on the market, into their cars. And these applications will allow these ubiquitous connectivity functions, especially mission-critical applications like the party emergency call, and also hazard warning and such things. And then further down the road, you know that with release 18, the 5G new radio and new radio NTN will arrive, and we believe that at around 2029 we will see the first mass market applications allowing wideband data rates at the end of this decade, at around 2029. Okay. And then it will take probably some years more, so that based on the new radio NTN, also broadband applications will appear. But for the broadband applications, we have a lot of additional challenges to solve. For these kind of applications, we are not able to use our existing radio equipment. We are not able to work in the frequencies we are used to, but we have to go to higher frequencies, frequencies which are not like 600 megahertz to, like, let's say 6 gigahertz, but we are talking about 15 gigahertz or even 30 gigahertz, very high frequencies, and these frequencies are also called Ka and Ku band. And for these frequencies, we would need very rather sophisticated directional antennas, which we also called so-called phased array antennas. And for these antennas, it is even more difficult to get them integrated into cars.
Okay.
And therefore, we believe these applications will also be, from our point of view, not a mass market application, but they will start as a niche application. And then we will see whether we will see new technologies or whether we see decreasing costs with increasing volumes. But you know, the next, we have a rather good picture on what will happen in the next 10 years.
Yeah, no, thank you for laying out that roadmap. That's really interesting. And right, I mean, the cost of a phased array antenna, it has to make sense. And right, it's like, what exactly is the business case for that? And why would, is BMW going to raise the price of the car? Is a person going to say that they're going to pay an extra amount? But I can understand that that's kind of what is one of the roadblocks. It's the cost of the antenna and whether or not that use case makes sense.
Exactly. Yes.
But it's really interesting to hear that, in just a couple of years, you think that narrowband IoT via satellite will be widespread on vehicles.
Yeah, I think we are very sure that this will happen. For instance, I just attended a conference from the company Wiresat in London, and they have invited all kinds of companies which are offering solutions for the narrowband IoT field. And this kind of market is now really exploding. Because so far there have been some proprietary solutions available, and now using that everyone is using the same standard, and where it is very easy that you can plug in additional devices. This is really driving the market. And also, what is very important to note. In recent times, you have probably heard more often the word direct to device.
Yes.
And this is exactly what we see here, that with release 17, 18, and 19, we see that it will be a common thing that cars and also handhelds and also millions of other devices basically connect directly to satellites, and the IoT applications will be the first ones.
Mm-hmm. With the consumer car, do you think that will be part of a standard package? Is it something that is just added into the safety features? Do you think it will be something that people have to pay extra for? What do you think that might look like?
Yeah, I mean, there are like two phases. On the one hand, from a technical perspective, I believe that that every car will be able to communicate with or via satellite, because you only need, as I said, if we are working in the frequencies which are already which you use already, like in the terrestrial frequencies, then you only need the Release 17 modem chip in your car. And then it's a matter on whether the automotive industry is then getting into business relationships with the telecommunication industry to integrate this kind of service. So the philosophy in general is that the automotive industry buys connectivity. And we believe in the long run, any MNO who is not integrating NTN will not be successful in the long run. And then, the discussion who is paying at the end and how this is integrated into the various services which are offered. This is just starting this discussion. But we can see already, like from the handheld services, that some customers, for instance, are willing to pay more compared to their terrestrial contracts. But this is really at the beginning of the discussion. Yeah. We can say or can speak here more from a technical perspective, that at least the technology will enable these mass markets. And then I believe that due to the growing number of applications, the dependency will grow, and also the willingness to pay.
Georg, did you have anything to add there about what the model might look like in the future?
Yeah, of course, this depends on each of the, let's say, car makers. Yeah. But I think in the 5GA, we have I think the clear view on safety-related use cases that will be served without any additional price tag. That's clear, mm-hmm. And that you already have if you have a terrestrial connectivity. So hazard warnings via satellite. My assumption would be that you will get somehow, when available, you get this for free. Yeah, it's obvious. And if you then tend more to infotainment or extended services, then there will be different models how to offer the digital services. But in principle, what Olaf said, the technology is now in offering us some very unique ability that we can have the hardware and everything enabled, so you can easily via a software upsell offer a functionality to the customer. Yeah, he doesn't need a new car. The car already supports this then from the hardware perspective, and you just have then perhaps an abo to get additional services.
Mm-hmm. How would you guys characterize how things have progressed in this area in the last few years? Would you say that, like, I'm not sure how long you've been looking at this area, but is there been a lot of movement just in the past few years, especially with the standards coming out, whereas, maybe a couple of years ago, this was farther out?
Yeah, definitely. So when BMW has started, you could already see like some major trends, starting with the introduction of Starlink some years ago. Until Starlink started to offer these broadband services from low Earth orbit satellites. There were mostly geostationary large satellites, which were catering to some customers on the ground with large antennas, and they basically were catering or serving to a few customers with high throughput. And due to the cost decrease for getting rockets into space, and you can see that SpaceX brings almost 2 to 3 loads of satellites into space every week. We are now talking about more than 7,000 satellites in low Earth orbit, just owned by SpaceX, bringing broadband connectivity to the world. And in the meantime, SpaceX also has started now with direct-to-cell services, where they basically get spectrum from terrestrial MNOs and already established the first direct-to-cell and direct-to-handheld services, at least in the US and also in Australia. But this is like one major player. Kuiper will follow soon. Both are still on a rather proprietary side, and all the incumbents which have their fleets already in the base now, most of them are changing towards standards. And for instance, some of the operators which are working in the so-called MSS spectrum, which is about 2 gigahertz, these companies, some of them are unifying now in the Mobile Satellite Service Association, where they try to come up with joint solutions, and they are driving for solutions which can be integrated into terrestrial networks based on global mobile standards. And you could also see that in some of the major conferences that 3GPP, direct to device, and standard-based solutions are now everywhere, and that's why we are quite sure that the last 2 years really have shown that the system is moving.
Georg, what do you think about the progress?
I think Olaf touched it very well. We have in the last 2 years an incredible move to allow us to bring satellite connectivity to the vehicles. Olaf said, of course, the driving forefront was broadband, as we mentioned Starlink. But you can imagine to have a Starlink dish on your roof. It's not feasible. So it's no designer would allow this, and we don't need it for hazard warnings that we just showed in Paris, for a basic connectivity. There we narrowband and wideband connectivity, and there was of course then this missing link that on standards that has been closed with Release 17. But what is now incredible? 2 years ago, colleagues or some other players said, standards can be standards, but will this be a driving force that there's a market uptake? And that's what happened is really incredible. We had, I think, one of the first automotive conference in Munich organized by 5GA, and it was ESA and DLR, and there you saw everybody, the different verticals were somehow a bit scared to be so close to the others. Oh, will we really work together? And today we sit together, we work out the solution how to make satellite connectivity on the automotive side happen. And that means we have now so many additional features in the further releases in 3GPP. But on one side, and we have now really a good track record on the chipset side to support this. So what happened? I have wished it, but what happened now and is seen on momentum. That's really very promising.
It's so interesting. I moderated a panel at Satellite. It might have been 3 years ago at this point. It might have been, it was 2022, and it was about the connected car. And at that point, the standards weren't out yet. And people were saying, yeah, it would be great, but who's going to pay for it? Why would you put a terminal on a car for, and there was discussion about how it was going to come about, but it seems like things have like really progressed a lot more in the last few years. So it's very interesting. I really appreciate having you guys on to hear from BMW. This has been awesome. Any final thoughts on the satellite connected car? I think you guys.
Yeah, maybe from my side. For me, it's all about cross-industry cooperation, and this is one of the lessons we have seen, what we have learned in the last years. There is in many topics there is not enough exchange between the various industries, and this is something where we need to come together to come up with joint solutions.
Yeah,
and that's for me the strongest lesson, that this is something where we need to like overcome that we are also competitors at some point, but I think this cross-industry cooperation enables then later on that new services will be developed and that new markets and new competition is rising.
Georg, did you have
anything to add from your side?
Yeah, I really can add so that I strongly wish that we keep the momentum, and a dream and vision is this 100% connectivity to be really real end of this decade, and then also and available, of course, on the handheld especially, but also on the automotive side, and here really serving the needs of the automotive industry and their customers.
Awesome. Well, thank you both so much. I really appreciate it. This has been an awesome discussion.
Thanks so very much.